Okay, in today's session we are going to see about multi-threading. What do you mean by a synchronization and a synchronization method and a synchronization block? Yesterday we have already gone through the synchronization with the help of our counter over here. We have gone through how this counter is acting in a synchronized matter. Now today we're gonna see about how a method will be acting as a synchronized way. Okay, further let me create a new class. First and foremost, let's go to multi-thread. So let the class name be called multi, and this will be having a main method. So here we are having a main method. So before that, let me create a class called bracket. Okay, this particular bracket is having a method. This method is generate method. Okay, what does this method generate is the question. This method is basically generating a set of brackets. Okay, let us say that I am generating some set of brackets. So I want 10 brackets, so for loop from 0 to 10, so that it will be giving me 10 brackets. In that, first 5 brackets will be in this way, opening. Okay, the next 5 brackets will basically be of closing type. Let me go back over here. Will be of closing type. After everything is done, line gap. Okay, this is my basically a generate method which is generating some brackets. So to access this, let me create simple object on my bracket, and final x is not needed. Okay, till now I hope you are clear.
Yes, sir.
Okay, now let me create a thread. So I am creating this thread in the way of implementing a runnable, and I am directly doing everything inside the main method itself instead of implementing it again. So here what I'm doing is I'm calling my generate method. So first and foremost, the generate method will give me only one line of data. Okay, closing 5, opening 5. I want to do this for 5 times. For that I am writing a for loop. Int I equal to 0, I less than 5, and then I plus plus. Sorry, I plus plus. So inside this, okay, I need to generate it. It's basically bracket dot. Okay, what is happening? BRA bracket dot generate, and then in the thread itself, I am starting this. Okay, till now this is normal. I'm creating a thread. I am creating a runnable interface. Inside that, I am activating my run method. So this run method basically I am activating like 5 times. Okay, now I'll simply run this program. Now you can see that I am getting some lines with opening and closing brackets. I hope till now there is no problem with anything.
Yes, sir.
Okay, now what I'm doing is I'm copying the same thing. I'm not doing any changes. I'm pasting it again, and I am rerunning the program. Now if you see over here, what is happening, this there are 2 threads created now, right? This is one thread and this is one thread, and these 2 threads basically are starting at a single time. That is called multi-threading, right? The ability to run 2 methods at a single time. So what is happening now? The run methods are both running at a single time. When it is running, there is a problem. So every time you rerun this, it will give you different types. So few times it is giving me properly, few times here it is giving me extra. And if I rerun this, you can see that according to my system's processor core speed, every time whatever it is happening, each thread is defining differently. Yes, but this is not how it should be. Basically, how many times I rerun it, it should be in the same format. It should be in a exact way. It should be like this, right? If I rerun it continuously again and again, what is happening is the depending upon my processor core speed, every time I rerun this, my thread's execution is not in a synchronized way. Okay, I need to make this generate method a synchronized method so that I will not be facing any issues. Got it?
Yes, sir.
Okay, so what is synchronization? See, synchronization is a process of imposing some restrictions on the thread. Okay, the process of imposing a restriction on the thread. What kind of a restriction? The restriction is to make it execute in a proper way. Okay, until and unless one thread is completed, you should not enter another thread. That is the way of putting it. It is a restriction basically. Okay, I am now restricting this method with the help of a keyword synchronized. Okay, now I put up a method, a keyword called synchronize to the method generate. So what is happening now? How many times you ever rerun this program, you will not get any errors. Not errors, it will always be in a synchronized format. Okay, understood?
Yes, sir.
Okay, we are imposing the restriction that until unless the first one is completed or the first loop is completed, you don't start the second one. We are imposing the restrictions to this generate method with the help of this keyword synchronized. And always remember, this synchronized will put up a monitor lock. Okay, the monitor lock is always controlled by the object. What is the object here? Bracket is the object, right?
Yes, sir.
So this is synchronized, is basically driven by object. Okay, suppose I copy this line, I create another object and I'll name it as bracket 2 and I'll name this as bracket 1. Now thread 1 is basically running with bracket 1 and thread 2 is running with bracket 2. When I run this, even though it is synchronized, come on, you will get the same kind of issue because it is basically driven by object. Before we had only one object and we created two threads with only that one object. Those two threads basically were running on a single object. So this synchronized keyword put a monitor lock on this particular object and then it was making everything to run on a synchronized way. But now what is happening? Through two objects are basically running. These two objects are will never be in a synchronized manner because the synchronized keyword is an object driven. Got it? So for that reason, basically when you are trying to do this kind of a thing, we basically prefer using one object other than two. Hope you understood how the synchronization on methods, how it is applicable.
Yes, sir.
Got it?
Yeah.
Good. Now what I'll do is someone's talking. Okay. Okay, now what I'll do is I'll impose some timer over here for sleep. Okay, I'm telling you to sleep for 10 seconds and instead of putting a throws, I'll simply surround it with try and catch. Okay, now here what I'm doing is I'm putting up another thread class over here, thread dot sleep. Oh, sorry, there is no need to put a thread class over here. Let me say long start will calculate the time taken to run this particular piece of program. Okay, this will be my start. I'll sorry, I'll copy this paste it over here, and I'll make this as end, and I'll simply print out my end minus start. Done. So the same thing whatever I am doing here, I'll copy this, I'll paste it over here. Okay, so now we can see that there is a small time gap. So now first of all, let's calculate it. See over here, it is very simple, right? Now if you see, when the process is running synchronous, it is synchronized. First one thread is implementing, after that the second thread is implementing, right? And look at the time taken. The first thread is 3:37, the second thread is 15:14. Okay, don't worry about that. Now I'll create another for loop inside my generate method. After this line, I'll create another for loop, and this for loop will be int I equal to 0. Let's say I less than 5, I plus plus. And this is not doing anything. This will just sleep for, let's say it will just sleep for around 25 seconds. Just surround it with try and catch. Done. Okay. Now let me run this particular piece of program. Let's see how much time it is taking. Okay, let me open up my calculator. So 1372 plus 2795, 4167. Okay, let me cancel this. Whatever the time I got, I'll simply create a multi-thread, and I'll write here as synchronize method. The time taken for synchronize method is 4167, 4167. Okay, now basically in this generate method, what is the most important block? There is two for loops, right? So our printing of brackets, our generating of brackets, which for loop is doing? Whether it is the first for loop or the second for loop?
First for loop.
Yeah, second for loop is basically not doing anything. So whether it isn't synchronized or not, it doesn't care. Instead of making the complete method synchronized, if I make only this block synchronized, that is enough, right? Assume that in a method there are multiple processes happening. Okay, multiple logics are running. But my intention is, if I only run this for loop multiple times or at a single time with the help of multi-threading, that is enough for me. There is no need of running this. So for if that is the case, if I just make this part as synchronized, that is enough, right?
Yes, sir.
So what I'll do is, I'll remove this synchronized over here. I'll highlight this. I'll surround this with the keyword synchronized, and this will take a variable. Just put this in this. Okay, what does this line means? This line basically means I am making all this with the help of this keyword. I am making all this synchronized. Okay, I don't want this to be in a synchronized format. I want only this to be in a synchronized format. Now if I run this program, you can see that the time is also reduced. And what is the total time? So 2121, sorry, 1212 plus 1,
253253.
yeah, okay, so 2537. So let me just go back to my Eclipse, and let me say synchronized block 2537. So instead of running this complete method as a synchronized one, you can run a particular block as a synchronized one. That process is called as synchronized block. And if you see here, why we use synchronized block? Because of the time. Okay, When we are using the synchronized block, the time taken will be reduced instead of using a synchronized method. Understood?
Yes, sir.
So that is for our multi-threading concepts. Okay.